Hello everyone, ASGF, this should be lesson 4 on slope. Let's get it going. So what is slope? Slope is a way of calculating how steep a function, specifically a linear function, is increasing or decreasing or potentially staying constant. So for example, here's an example right here of an increasing function, linear function that is. Here is a decreasing function, right? Its slope would be negative. So we've got increasing function, that should be a C. Increasing, decreasing, and constant would be a horizontal line. So the slope of an increasing line would be positive, the slope of a decreasing line negative, and the slope of a constant line will be 0. Slope tells us how quickly a line is rising or falling. The slope is calculated by taking the vertical change, called the rise, divided by the horizontal change, which is called the run. For example, this line right here rises 1, 2, 3 units for every 1, 2 units that it moves to the right. Therefore, its rise would be 3, and its run would be 2. So its slope, which we refer to using the letter M, would be 3/2, or 1.5. All right, let's look at a few examples of how to calculate slope. Before we look at calculating slope, as you can see here, we see a positive slope increasing from left to right, a negative slope decreasing, a 0 slope or constant slope of 0, yes, and a undefined slope. This is a vertical slope. All right, let's look at a few examples and do some calculations. Yet again, I'm ahead of myself. First, let's go over how to calculate slope. Given any 2 points, notice x1, y1 like we looked at with midpoint, and x2, y2. Okay, we've got 2 ordered pairs. We take the y value minus the other y value divided by x minus x. Now it does not matter. You could do y1 minus y2 as long as you operate x1 minus x2. So the order does not matter whether first point or second point is first. However, we have to keep them in the same order, both top and bottom. All right, let's do some calculations with those. Okay, 2 examples using the calculations. Here I've got my x values, x1, x2, y1, y2. Let's calculate the slope of problem number 1. I'm going to take y2, which is 7, minus y1, which is 1, divided by x2, which is 3, minus x1, which is negative 2. That calculation gives me a positive 6 over a positive 5. Or, if we wanted to write it as a decimal, that would be a slope of 1.2. Okay, problem number 2. x1, x2, that should be a 2, not a piece of spaghetti, y1 and y2. y2, which is negative 5, minus y1, which is a negative 2, over x2, which is 7, minus x1, which is 7. Now this is interesting. We end up getting negative 3 over 0. What does that mean? That is our rise. This is our run. Let's sketch this. I've got 7, negative 2, and a 7, negative 5. This is a vertical line. A vertical line does not have a slope that we can calculate. So this is an undefined slope. Okay, you could use the letter U. You could write out the word undefined. That slope would be much different than if we had 0 over negative 3. That would be a slope of 0, which would be a horizontal line. Okay, let's look at a few more examples. All right, this is an interesting example. It says given that we have the point x1, y1, which is negative 4, negative 2, and a second point for y, which I'll call x2 and y2, and the slope between the 2 points is 1/2. Find the value of y. Okay, so I'm going to take y2, which I'm going to call this value here, this unknown y value. I'm going to subtract y1, divide by x2 minus x1, and set it equal to 1/2. So we get y plus 2 over 8 is equal to 1/2. Okay, a couple of different options here. You might notice that 1 is to 2 as something is to 8. Well, you might say, well, this has to be 4, and you'd be right. Right? I want this ratio here to be equivalent to 1/2, and 1/2 of 8 is 4. Okay, another way that you could do this would be to cross multiply. If I cross multiply, that means I'd multiply 8 times 1, which gives me 8. And I multiply 2 times y plus 2. I have to be careful here using order of operations appropriately and distributing. So I would get that 8 equals 2y. I distribute by multiplying, as well as 2 times 2. So if I subtract 4 from both sides, I would get 4 is equal to 2y, which means that y is equal to 2. Okay, let's backtrack again to the original method that I was talking about. So y plus 2 over 8 is equal to 1/2. Using proportions, I know that 1 is to 2 as 4 is to 8. Therefore, I know that y plus 2 must equal 4. What did I do? I moved all the way down to an expression equivalent to this. Okay, and when I subtract, I get y equals 2. Either way you get there is totally fine, as long as you get that correct answer showing enough work. All right, let's look at a couple more examples. Okay, very similar example here. Here's x1, comma, y1. That was the weirdest y of my life. There's 8, comma, x2, comma, y2. And let's find y2. So I'm going to take y minus a negative 4 and 8 minus a negative 8, set it equal to 3/4. Okay, do a little work here. So it'll be y plus 4 over 16 is equal to 3/4. Well, what is 3/4 of 16? Watch another way that I can do this. I'm going to multiply both sides by 16. So the left side becomes just y plus 4. The right side, 3/4 of 16, is 12. So if I subtract 4 from both sides, I get y equals 8. There you have it. All right, a couple more examples. Let's keep rolling. Okay, here it's asking us to find the slope of the following line. I'm going to use 2 points that I can definitely tell their locations. This point is going to be the point 220. This point is the point 480. So to find the slope of this line, I'll take y2 minus y1 over x2 minus x1, which will be 60 over 2, which is equivalent to 30. So our slope is 30. Okay, one more example and we'll call it good for today on slope. Interesting question says find the coordinates of 2 more points on the line that passes through -2, 4, and 5, -1. Okay, so let's think of how we will do this. Here's the point -2, 4, and approximately here's the point 5, -1. So here's the line that passes through those 2 points. Okay, so let's find the slope between these 2 points. That might be helpful, seeing that this lesson is on slope. I'm going to flip it around and go y1 minus y2, so it's 4 minus a -1, divided by -2 minus 5. That looks to be a +5 over a -7. Okay, so what's really happening here is if I go from one point to another, Okay, it looks like I would be rising, or in the y direction, adding 5, and running, or in the x direction, going left 7. So let's see what that looks like. So I went left 7 in the x direction and up 5 in the y direction. So I could do that again. And that would find me a point right here. I don't know what that point would be, but I could do that calculation. And likewise, in the opposite direction, which would find me a second point on that line. Okay, so let's subtract 7 in the x direction and add 5 in the y direction. Well, in the x direction, I'm going to subtract 7. So if I subtract 7 from -2, I get a -9. If I add 5, oh, my Apple Pencil, oh no. Poor little guy's got charged. All right, I'll be right back. All right, let's see if we're functioning again. Oh yeah, there we are. I add 5 and I get a +9. So here is a second point, a first point on that same line. Let's do the same here. Now, interestingly enough, I'm not going to add 5. I'm going to actually subtract 5, right? Because I want to travel this way. Okay, so I'm going to subtract 5 and I'm going to add 7. Okay, so now if I subtract 5 and add 7, oops, I got those flip-flopped. If I subtract 5 from the y and add 7, I would be at the point 12, -6. There is my second point on that line. And there you have it, guys. That is a lesson completed on slope. Have a great one. See you in the next video.